Hello, Math 2. This is Mrs. Bricky, and this is Unit 9, Lesson 1, Introduction to Complex Numbers. So I have two equations here that I want us to start by solving. Based on our prior work with quadratics, you should have a strategy that you can use to solve these, and the strategy we're going to use is called the square root method. And knowing what we know about quadratics, you should know that we will have two solutions, because all quadratic equations have two solutions. So this first equation, x squared equals 9. A lot of times people want to say 3, but there are two solutions, remember? So if we take the square root of both sides of an equation, we have to remember that there is two answers to this, a positive and a negative answer. So we put a little plus or minus symbol there to help us remember that we've got our two answers. So if we take the square root of x squared, we get x equals, and on the right side of our equation, we have positive and negative 3, because the square root of 9 is 3. Remember that plus or minus symbol is just shorthand. It just means that we have two answers, positive 3 and negative 3. And again, remember that those are our two answers because either way, if we square them, we get 9 back as our answer. So both of our solutions are correct. Okay, so the next equation, x squared is equal to negative 9. So we can approach this exactly the same way. We're going to take the square root of both sides of our equation. Don't forget positive and negative. And on the left side, we have x is equal to positive and negative. And if you type into your calculator the square root of negative 9, you get a domain error. Your calculator can't do it. But I've told you over and over again, our quadratic equations should have two solutions. And this equation does have two solutions, but we can't find those solutions yet. And that is our goal for today, is to figure out what these solutions are. Because they do exist, there are two solutions. You just don't know how to find them yet. So I wanted to connect these two equations to graphs just because I think it's interesting to have a visual of it. One way I could think about the equation x squared equals 9 is to think about the x squared parabola, which is just a parabola with its vertex at the origin, and to think about when will that parabola equal 9 or have a height of 9. And so if we think about the height of 9 on that parabola, it hits that value 9 twice. Once at 3 and once at negative 3. So x squared equals 9 has two solutions, positive and negative 3, just like we said before. It's just kind of interesting to look at the graph and see it. So if we want to think about x squared equals negative 9 as this graph idea, it's the same parabola, that x squared parabola, but it's never going to have a height of negative 9. Our parabola lives up here in quadrant 1 and quadrant 2, and negative 9 is way down here in quadrant 3 and 4. So x squared minus 9 has no real solutions. This is our real coordinate plane with all of our real numbers represented on it. It has no real solutions, real being a very specific math word that we'll talk about in a second. It does have two solutions, but they are not in the number system that you are used to using. So when you first started school, or even before school, I guess, you learned to count. And when you learned to count, you were using the whole number system, like 1, 2, 3, 4, 5. And then you got a little older, and in school, you started learning about fractions, which are rational numbers. And so you expanded your number system a little bit so that it included more than just those whole numbers. It included rational numbers. And then you started learning about not just positive numbers, but your teachers started teaching you about negative numbers as well. And negative numbers are integers, like negative 3 and negative 8. And then, rational numbers could also be negative as well. They could be, negative 2/3. So you started operating in the rational number system. And then eventually, probably around 6th grade or so, you started learning about irrational numbers like square root of 5 or pi. Irrational numbers are numbers that can't be represented as fractions. And if you look at their decimal expansions, they go on and on and on forever. They don't truncate or repeat. So it took you like at least 12 years of your life to sort of learn about all these different numbers. And all of those numbers are part of what we call the real number system. And that number system that you've been operating in up to this point, in that number system, anytime you square a number, you get a positive number back. So if we square, -7 halves, we get a positive number back. We get 49 fourths. Or if we square, I don't know, the square root of 7, we get back 7. But no matter what number we choose to square in this real number system, the answer that we'll always get is positive. So if we're trying to think about what number squared gives me -9, or what number squared gives me any negative number, it's not going to be a number in the real number system because all of the real numbers square to give us a positive number. So the answer to the question, what number squared gives me -9, it exists in a different number system, and that number system is called the imaginary number system. And the imaginary number system is all of the numbers whose squares are negative. And some quadratic equations have these other types of answers. So quadratic equation always has two answers. Sometimes the two answers are in the imaginary number system. I know the word imaginary sometimes gives people a problem because they think that it means that they are pretend numbers. But in this case, imaginary is just a name that they gave the numbers. Descartes didn't really like the numbers, and he sort of gave them the word imaginary, the name imaginary, as kind of a derogatory term. But they do exist. They are not pretend. They are just a new type of number, and the name that mathematicians chose to call them is imaginary. So the definition of imaginary numbers, like the very, very most basic imaginary number, is I. So we use a letter to represent imaginary numbers. So their very, very, very most basic imaginary number is I. That's the unit in the imaginary number system. And I is equal to the square root of -1. So square roots of negative numbers don't exist in the real number system. So these are numbers in the imaginary number system. And so we can get other imaginary numbers that have an I with them. So, for example, we can have the imaginary number like 7i or -2i. But I is like the most basic. It's like 1i. It's just the very most basic number. So if b is a positive number, any positive real number, and if we have a negative with that b under the root, then that's the same as the square root of b multiplied by I. So for example, if I have the square root of -100, I can think of the positive square root of 100 and then multiply it by I. So the square root of -100 is 10i. And imaginary numbers are a little bit weird at first, but you're going to be very good at them. You'll start to feel comfortable pretty quickly, and you'll get very, very good at operating with them. So we're going to simplify a couple radicals here. So we've got the square root of -4 to start with. So remember, we can always think about the positive square root, and then the negative tells me that's going to be imaginary, the negative inside the root. So the square root of 4 is 2, so the square root of -4 is 2i. You can always use your calculator to help you out here, but you have to be smart about it. If we type into our calculator the square root of -20, our calculator is just going to say error. So you have to be smart about how you think about it. You can think about the positive square root and then multiply it by I. Now this one is a little different because the square root of 20 is not a whole number. The square root of 20, if you use your calculator to simplify it, is 2 root 5. So it's 2 root 5 multiplied by I. However, mathematicians are not always notorious for their good handwriting, and you are not always notorious for your good handwriting. So unfortunately, writing the square root of 2 root 5 multiplied by I can get a little ambiguous. Like if you're writing fast, it kind of sometimes looks like the I is underneath the root, or the I can start looking a lot like a 1. So what we want to do instead, what is more customary, is if we do the I with the 2 and then put the root after it. So if you have a whole number, it's customary to put the I after the whole number, like 2I. If you have a root, it's customary to put the I in front of the root. So if you have both a whole number and a root, the I usually just gets sandwiched right in between. And the main reason for that is to make sure that does not look like the I is under the root, because it really can look like that with people's handwriting. Okay, so both of those were imaginary numbers. This next one has a negative in it, but the negative is outside of the root. This is not an imaginary number. This is a real number. So it's a negative real number though. The negative in front is just a negative. So this is negative 2 root 5. So just really watch out. If you have a negative under the root, that means it's an imaginary answer. A negative under the root means it's an imaginary answer. A negative outside the root just means that it's a negative number. It's not imaginary. I mean, it could be a negative imaginary number, but in this case, it is just a regular negative number. Okay, so here's a couple more to try. Square root of negative 32. Well, if you type in root 32 in your calculator, that's 4 root 2. This is an imaginary number. Oh, 2 looks terrible. This is an imaginary number because we've got a negative inside of our root. So our number is going to be 4I root 2. The next one is negative root 9. The negative is outside the root. This is just the real number, negative 3. And then the last one, you have a negative both inside and outside. So mine has a little typo there. So the negative outside means that we've got a negative answer. The negative inside means we have an imaginary answer. The square root of 25 is 5. So the negative root of negative 25 is negative 5I. And again, the negative here just means we have a negative answer. The negative here means that we have an I, and the square root of 25 is 5. So our answer is negative 5I. Okay, couple true or false questions. The square root of negative 49 is negative 7. Think about it for a second. This is false. This negative means we should have an imaginary answer. The real answer should be 7I. The second problem, we've got negative root 54. This negative is outside of the root. It just means we have a negative number, and we have a negative over here, so that's perfect. And root 54 does simplify to be 3 root 6. So this is true. It is not an imaginary answer. It is just a negative answer. Okay, we're going to try to plot all of these radicals on the number line, but this is a real number line. I don't see any I's on there. So if any of these expressions are imaginary numbers, we will not be able to plot them. We will just circle them up. Only real numbers can be plotted on this real number line. So our first number is negative square root of 9. Well, that is the same as negative 3. It's a real number, and it would get plotted right here. Negative root 9 goes right. Our next number is the square root of 25. The square root of 25 is the same as the number 5. So that's going to go over here. Our next one is the square root of negative 9. Well, that negative inside the root means this is an imaginary answer. It is 3I. And because it is imaginary, we cannot plot it. We'll just circle it up. The square root of negative 36. Well, that's the same as negative 6. That's a real number, so we can plot it on our number line. And our next one is negative, let's see, the square root of negative 8. Simplified, that would be 2I root 2. That is an imaginary number, and so we cannot plot it. We'll just circle it up. The square root of negative 4, we actually simplified a minute ago. That one is equal to 2I. This is also an imaginary number, so we'll circle that one. Our last one is the square root of 5. We like to leave things in radical form, and we're going to leave it in radical form as we plot it down here. But to know where to plot this, we need to know about what decimal value that is. So if you're doing it in your calculator, you're going to look for that little button that has the arrows in each direction. That's a converting button. So if you type in root 5 and hit that converting button, which is just above your enter or your equal button, then it'll convert that to decimal, and that is approximately 2.2. So this is where root 5 goes. Now, we don't necessarily want that decimal. Like, you want to keep things in radical form as much as you can, but just for knowing where to plot it, we need to get the decimal. All right, so if you have your assignment, you should pause the video and practice the front side of the assignment, and then I'm going to continue the video, and you could work on the back side after that. All right, so now we're going to circle back to solving equations, because I told you that x squared equals negative 9 has two solutions, and now I bet you could find those two solutions even by yourself without me telling you, but I'm going to do it with you anyway. So if we root both sides of this equation, we do get for our equation a positive and a negative answer. So our answer is x is equal to positive and negative. The negative inside means our answer is imaginary, and the square root of 9 is 3. So our two answers are positive and negative 3i. So we're going to solve a few more equations to practice that up, and also to look at a couple other scenarios that can come up. So remember, when we're using the square root method, we need that x squared to be by itself before we root both sides. So in this next equation, we are not ready to square root yet. We want this x squared to be alone first. So my first step is going to be to subtract 35. So I get 2x squared is equal to negative 32. The x squared is still not by itself right now. It has a 2 with it that's multiplying it. So we're going to divide both sides of our equation by 2. And now we have it isolated. Now we have our x squared by itself. We have x squared is equal to negative 16. So we are ready to apply our square root to both sides of the equation. On the left side, we're left with an x, and on the right side, we have positive and negative. The 16, square root of 16 is 4, and this has a negative inside the root, so we've got an imaginary answer. It's positive and negative 4i. Let's try another one of those. Negative 140 is equal to 5x squared. So we need that x squared by itself. So we're going to go ahead and divide both sides by 5. So I have x squared is equal to negative 28. Negative 140 divided by 5 is negative 28. We're ready to apply the square root to both sides of the equation. We know we have two answers, a positive and a negative one. And we get x squared is equal, not x squared, we just rooted it. We get x is equal to, so root 28 in your calculator is 2 root 7. We have a negative under our root, so we know we have an imaginary answer. And remember that the place that we want to put that I is between the whole number and the root. So the x is equal to positive and negative 2i root 7. And those are our two answers. And again, remember the positive and negative symbol just means that we have two solutions. One of the solutions is a positive number and the other one is a negative number. Okay, well, some of our equations are going to be that basic, but some of our equations are going to be a little bit more complex, like these. So you have actually practiced solving these before in our last quadratics unit, But I want to review. So this first one is one that we have done very similar before in our real number system, and then we'll look at one that has some imaginary parts to its answer. So I want to review this first one, but they're very similar. So how these are different from the ones we've been working before is that it's not just an x being squared, it's a binomial being squared. So we still want to get this square by itself. So we're going to start by adding 6 to both sides of the equation. So I have x minus 5 squared is equal to 6. I have my square by itself now, so I'm ready to apply the square root. So now I have x minus 5 is equal to positive and negative root 6. Now, that root 6 doesn't simplify. If you type it in your calculator, it'll just spit a root 6 back out at you. Okay, so on the left, I have x minus 5. My goal is to solve for x, but I have not gotten that x by itself yet because right now it still has that minus 5 with it. So we need to add 5. Now, 5 is a whole number, and we are trying to add that whole number to an irrational number. Now, we can definitely add them together because they both are in the real number system. We could get a decimal approximation for that, but oftentimes what's preferable is to just leave our answer with those two parts. The whole number part, the real rational part, and then the irrational part separately. And we just leave it like that. And we've had lots of answers in the past units that look like that, and that's an absolutely okay answer. And we definitely could get the decimal if we wanted, but that's a solid answer. It's a real number that just has a whole number part and an irrational number part. Now, some of our imaginary answers are going to look that way too, where we have the two parts that don't combine. So let's look at this next equation now. It looks really similar. So our first goal is to get this binomial that's squared by itself. So we need to subtract the 4. So we get x minus 5 squared is equal to negative 4. We have our binomial squared by itself. Our square is isolated, so we're ready to square root both sides, and that will just give us an x minus 5 on the right. So positive and negative root 4 and root negative 4. So on the left side of the equation, I have x minus 5 and positive and negative, and we practice the square root of negative 4 at least twice now. That is 2i. Square root of 4 is 2, and we have an imaginary answer because of that negative that's under the root. So we're not quite finished. We have one more step to finish solving for x. We need to add 5 to both sides of our equation. Now that 5 that I'm adding is a real number 5. It's a whole number 5 in the real number system, and the 2i is in the imaginary number system. Like part of my answer is in this system and part of my answer is over here, and those two parts do not combine. So we have to just leave our answer with two parts, just like we sometimes do with irrational parts as well. And that is going to be our final answer, 5 plus 2i and 5 minus 2i. And it really is just two separate answers. One of them is 5 plus 2i, and the other one is 5 minus 2i. And the plus or minus symbol is just shorthand, so we don't have to write both of those numbers out separately. Okay, I have one last equation for you to work on with me. So we have x plus 7 squared, and that's equal to negative 80. So the binomial square is by itself. We're ready to apply the square root, plus and minus. So on the left side, we have x plus 7, and the square root of 80 is 4 root 5. So since this is the square root of negative 80, we have a positive and a negative answer here, and it's going to be 4i root 5. We put the I after the 4, but before the root 5. And we're not quite finished with our problem because that's x plus 7, and we want to solve for x. So our last step is to subtract the 7. Now, since the plus or minus there is an imaginary part, we don't want to combine that negative 7 with it. So we are just going to keep those two parts of our answer separately, the real part and the imaginary part. And this would be our final answer here. So is it called a complex number when it has both a real part and an imaginary part? Okay, so today's big idea is that I is an imaginary number that is equal to the square root of -1. And when we say imaginary, we don't mean pretend. So that means, if I think about, okay, I know that I is equal to the square root of -1, I squared would be if I square both sides of this equation. So I squared is equal to, if I square the square root of -1, this is just -1. So I squared is equal to -1. So next class, we're going to use this idea to help us. And next class, we'll be focusing on numbers like 2 minus 4i, and those are called complex numbers. And we're going to be learning how to add and multiply complex numbers. So something to look forward to. So you should have enough information to finish up the rest of your worksheet on 9.1. When you're working on solving equations, not all of the answers will be imaginary. Some of them are going to be real number answers. And also, depending on your teacher, you may have Edulastic 9.1, which is 4 questions. So if your teacher is assigning you Edulastic, then make sure you do that. Those 4 questions should only take you a couple minutes. Alrighty, thanks a lot.